Did you ever consider gaming on a virtual machine? I did. Today we're going to build a Linux and a Windows VM on Proxmox just for game streaming, using a real GPU passed through the VM. This way we can play games anywhere, using a laptop or cheap handheld or whatever you'd like to use. Let's get into it, after the intro. I'm using this Simmerboard 2 as a host, because I'm curious how a GPU will do in its PCI Express by 4 slot. For a GPU, I will first try this GTX 745, simply because it's the most power efficient card that I have. The Simmerboard 2 with its 60 watt power supply simply cannot drive a 75 watt card, so if you want to use this thing with anything more powerful, you probably need external power. Let's first build ourselves a Windows VM. Let's just call it Win11. I'm using the LTSC image because it's lower on resources, but any Windows 10 or 11 variant will do. Change the OS type to Windows and tick this box to add a drive for the guest tools. You can download those from fedorapeople.org/groups/virt.io-win/direct-downloads/latest-virt.io. By the way, the Q35 machine type is perfect. Virt.io SCSI is fine as well. We do want that Qemu agent. Not sure why you would leave that out, to be honest. Let's make the drive 120 GB for this test. If you have more to spare, that's obviously better, as games get bigger and bigger nowadays. Tick the discard box, so deleted files will actually free up space on the host as well. Let's give it 4 cores, which is the maximum we have available in this little unit, and we want them to be of the host type. Again, I'm not sure why that simply isn't the default. About 12 gigs of RAM. Again, more would be better, but there's only 16 in this unit. Now the networking part. Do change that to E1000. It's not the most efficient choice, but somehow game streaming doesn't seem to properly work when using the Virt.io adapter on the current version of Proxmox. All I got was a big black screen, until I changed the adapter to E1000. Now install like normal. I'm choosing the IoT variant to save resources. Oh no disk! That's where the Virt.io driver CD comes in. Click Load Driver, navigate to the VIO SCSI folder and the subfolder for your Windows version and architecture. Click Install and boom! There's our drive. Ah, crap. Yeah, let's disconnect that network adapter for a moment. That's better. Alright, first thing to do is to get the guest tools installed. So let's navigate to our Tools CD and click Virt.io Win Guest Tools. This will install all drivers and such to have Windows behave well in a Qemu VM. Now we'll enable remote desktop access, because we're going to change the graphics card over to our GeForce card in a minute, and there's no display attached to that card. First, we need to set a password though. Password hint? I don't know. Now search for remote and simply enable remote desktop by flicking the switch. Next thing I want to do is to configure auto login. Why? Well, you might want to directly start a game from your streaming client, and that's simply not possible if no user is logged in. For this to work in Windows 11, we need to open the registry editor. Navigate to HiveKey local machine, software, Microsoft, Windows NT, current version, passwordless, device, and change the value of device passwordless build version to 0. Now run netplwiz and uncheck users must enter a username and password. Select the user you'd like to automatically log in and click apply. Enter that user's password and it's done. Alright, let's enable that network card again. And while we're at it, get that GPU connected as well. There's my GeForce card. Select all functions, so we get the audio sub-device as well. Make sure to tick PCI Express under the advanced options, or the card won't work at all. And we'll tick primary GPU, which will effectively disable the virtual graphics card. This simply because we don't want our game stream to open on the wrong device. Start the virtual machine again and keep an eye on the status page. As soon as memory usage is less than 100%, you'll know the guest agent is running. And as soon as there is an IP address, we should be able to connect. Oh, it's the other way around. Oh well. Personally, I'd like to wait a moment longer until CPU usage quiets down a bit. Alright, let's try to connect. And we're in! Let's search for the latest drivers for our GPU on Nvidia's website. And install. Cool, drivers are working and from earlier this year. Let's download Apollo, our game streaming service. This is a fork of Sunshine with a virtual display included. There seem to be other improvements as well, but the virtual display is my main reason for getting this one, as it saves us some headaches on a headless virtual machine. Just install that, run it for the first time, and you're asked to create an admin user and password. After that, the service restarts and we can log in. Let's see if we can connect. Go to pin pairing. Here's Moonlight, the client for Sunshine and Apollo. It has already found my VM. Click on it and you'll be presented with a 4-digit code you need to enter into Apollo. Give it a name and that's it. The first device you'll enter will have all rights enabled. For any new ones, you'll need to click the things you want the client to have access to yourself. Oh, I'd almost forget. Since we're running a headless system, we'll need to go to the Configuration tab, click Audio Video, and tick the box next to Headless Mode. This way a virtual display will be opened on Connect. Sunshine and Apollo need to connect to a display, and there's no real display connected here. Alright, let's connect! There we are, back in our session, but now through Apollo. Time to download and install Steam and a few games.
Over crest, into left 5, 30, right 5.
WRC7 runs quite a bit slower than in my previous test of this GPU at 720p resolution. Not too surprising, as it's not only limited by the by4 slot, but it's also handling the stream encoding right now. Still reasonably playable, especially since I'm now able to race on a handheld that can't play this game at all. The same can be said for Borderlands 2 at 1080p. If you want to be able to start the game without going through the desktop or Steam's big picture mode, you can open Apollo's config again and navigate to the Applications tab. Here you can add all of your games manually. Let's check the command in the Start menu item. Click Save and... oh! There it is! Alright, let's try this on a Linux VM as well, shall we? I've downloaded CacheOS, as that one seems pretty popular. Create VM, let's just call it Cache. This defaults to an i440FX VM, which is not good as it doesn't allow PCI Express pass-through, so we changed that to Q35. The same goes for the BIOS. We need to change that to UEFI for this to work. Enable the Qemu agent again. Still wondering why that's not ticked by default. Let's make this one 100GB and make sure to tick the discard box. 4 cores of the host type, 12-ish gigs of RAM. The VirtIO network card is fine for Linux. Let's go! It would not run the CacheOS live image until I entered the BIOS setup and disabled Secure Boot. I don't know, does Cache not support that? Who needs it anyway? Install like normal. It defaults to the Lemine bootloader, which is fine by me. Plasma desktop? Sure, why not? Alright. Install apps. There's no Apollo here, so we'll go for Sunshine. Oh, and the NVIDIA driver while we're at it. Let's enable auto login for Linux as well by navigating to Login screen in System Settings. Click Auto Start and add Sunshine so it will start right after logging in. Alright, let's add our GPU again. This time we'll leave the primary GPU box disabled because we're not done configuring yet. There we are, automatically logged in and Sunshine is running. Let's click it to configure the service. Again, create a very secure username and password. I guess that I should mention that you can only open this interface from inside the machine by default, so not that big of a deal. Do the pin pairing dance again. What's my IP? Oh crap, I forgot the guest agent. Let's quickly install that first. There's our address. Ah, damn it. Let's just disable the firewall. Who cares about security on a local game streaming machine? There we are, still connected to the virtual display adapter though. We need a virtual monitor to connect to our GPU before we can use that. Luckily, the Linux kernel is able to virtually connect a fake monitor to a free port using an edit file. This page explains this in more detail. Don't worry, I'll leave a link to this page in the description. First we need to download a file for the kind of monitor we want. I'll just pick the first HDMI one here. Create an edit directory on the USR lib firmware and move the file into that directory. Find the name of the first HDMI port. Why won't this? Fish. Just run bash. My HDMI port is exactly the same as the example on this page, but your mileage may vary. Edit the kernel command line, in my case etc default limine, because Cache is using that bootloader. Change the name of the edit file to the one that we have just downloaded. Now we need to make sure that the edit file is already available in the boot image, so we add that path to the file etc mkinitcpio.conf. Next we need to run mkinitcpio-P to make it happen for real. Warning! This does not update Limine boot entries. Yes, please fix that for me. Let's reboot. Look at that! We suddenly have an Acer monitor attached to our system. Okay, let's shut down the VM and make our GeForce the primary GPU. Let's wait for the VM to calm down again. It works! Woohoo! Now we can finally play Super Tux Kart on any device that has a Moonlight client. In terms of power draw, this setup uses around 10 watt idle with no virtual machines active. When the Windows VM is running but not doing anything, it uses some 3 to 4 watt extra. It's very similar when the Linux VM is active but idle. When I run a GPU stress test, this goes up to around 60 watts, so close to the maximum that the power supply is rated for. I didn't see anywhere close to that during an actual gaming session though, so there's not much to worry about here. Last but not least, I wanted to try a better GPU. As mentioned before, the Simmerboard 2's power supply is unable to drive more power-hungry cards that need power from the slot, so our 1050 Ti for instance is out of the question. Let's see if it can drive my RX 5700 XT. Oh, yeah, this is fine. This needs an external power supply to connect to the two 8-pin connectors on top. Now we need to power this PSU on, which you can do with a paperclip. Bridge the 4th and 5th pins on the connector when holding it like this. Then turn the power supply on and... Phew, no smoke. Let's power on the Zimmer board again. To get this card to work, I needed to blacklist the AMD GPU driver and, just to be sure, the Radeon driver as well on the host machine. Otherwise the GPU would be in use and the VM would not start. To do this, make a file in etc/modprobe.d like stoptouchingmycard.conf and add blacklist AMD GPU and blacklist Radeon. Next run update init ramfs -u -k all to update the boot images. This blacklist action stops those drivers from being loaded and grabbing onto the GPU. Let's update the VM config and choose the RX 5700 XT this time. And boot. We've got a nice green bar at the bottom, totally for free! I don't care enough to fix that right now. 1080p very high, doing a lot better this time. Nice! I think we're limited by our by 4 slot, but it's quite a big improvement anyway. Black Mesa 1080p and the highest preset? Not bad at all. SuperTux card runs very nice as well. Cool! So, would this be a good idea? Well, maybe not using the Zimmer board too, but you can. You can use the exact same steps on any machine running Proxmox though. Or even anything that can run Qemu, which is quite a lot. That's all I have for you today. I hope you liked this video. Thank you very much for watching. Until next time.